Today we're going to simplify expressions using perimeter and area of rectangles. Our goal is to use familiar formulas to simplify expressions. In this lesson, you are going to apply what you've already learned about perimeter and area of rectangles and squares, and you're going to use that to simplify algebraic expressions. So let's review. The area of a square, we remember, is the side squared. The reason why we only need to multiply one feature is because all the sides are always the same in a square. The perimeter of a square is, of course, 4 times the sides, or all the sides added up together, which, of course, they're always equal numbers in a square. For the area of a rectangle, well, a rectangle has opposite sides parallel, and opposite sides are the same measurements. So we know that the area is the length times the width. The perimeter of a rectangle is 2 times the length plus 2 times the width, because of course the top and the bottom are the same and the opposite sides are the same as well, or length plus width plus width. Those are both the same. What does that mean when we have figures? Well, in this case we of course could see, well, the area would be 6 times 6, or 6 squared, which gives us 36. The perimeter would be 4 times 6, or 6 plus 6 plus 6 plus 6, which is 24. And these, of course, would be units, or units squared. The area of a rectangle, of course, is the length times the width. So in this case, it would be 12 times 5, which would give you 60 units squared. And the perimeter, of course, would be 2 times the length, which is 12, plus 2 times the width, or 5. Or I could just add 12 plus 12 plus 5 plus 5 and get 34. And this would be units. Some common mistakes: students will say square units for perimeter when they should only say square units for area. And of course, students will reverse the formulas. It is important to note that the area of a square is a rectangle, so you can use the same formula for a rectangle as a square. However, a rectangle is not always a square, so you cannot reverse both formulas both ways. But if there's one formula you want to focus on, it's this, because it'll work for both squares and rectangles. So how do we use a formula we are already familiar with in order to simplify an expression? Well, we're going to use perimeter and area to simplify an expression for each of these. So let's first look at area. We know that the area of a rectangle is the length times the width. Well, we can just plug in our length. So we have area equals, and then 1 6/10 n times, and I'm going to use parentheses for my multiplication, the width, which is n. Common mistake: students will multiply n times n and get 2n, but if you look in previous tutorials, n times n is n squared. So my area equals 1 6/10 n squared. Let's look at perimeter. So my perimeter, again, I have if I wanted to add 1.6 plus 1.6 plus n, I could also do that. But I prefer 2 times 1 6/10 n plus 2 times n, which I can put in parentheses, but of course you probably know 2 times n is 2n. So now I have my variables in place of the L and the W. What can I do next? Well, I can double 1 6/10 n's. So 1 6/10 doubled is like 16 doubled, so that is 3 2/10 n plus 2n, which of course 3 and 2/10 n plus 2 n's is 5 wholes and 2/10 n's. So now I've simplified my expression. Let's look at another example. Write and simplify expressions for the perimeter and area of a rectangle. So here we see that we have x for the width and x plus 10 for the length. So here we have to use our good old friend, the distributive property. So let's first look at the area. So we'll plug in what we know. Area equals x plus 10 times x. And of course, my commutative property of multiplication says that I can reverse the order, but I need to remember my distributive property rules. So I always want to do my parentheses first, but if I can't do what's inside the parentheses, for example, x plus 10, I can redistribute the numbers to simplify an expression. So if I multiply x times x and then x times 10, then I have an expression that can be simplified. Area equals x times x, which is x squared, plus x times 10, which is 10x. Now I cannot combine x squared and 10x, so my simplest form is area equals x squared plus 10x. Now looking at the perimeter. Well, again, I can plug in what I know. Perimeter equals 2 times x plus 10 plus 2 times x. Again, I need to use the distributive property to redistribute. P equals 2x plus 20 plus 2x. Now, we move that down. We can combine. Our commutative property, of course, means that we can change the order to 2x plus 20, which gives us P equals 4x plus 20. If you need to review simplifying expressions, make sure you look at previous tutorials. So now we have a simplified answer for both our perimeter and our area. And whenever we have a number that's x minus 3 or x plus 4, 2x minus 8, those are all problems that we are probably going to have to use the distributive property on. Let's look at one more example. A square picture with unknown sides is inside a frame with a length of 9 and a width of 6. Write an expression for the area of a frame. Well, we know that the area of a rectangle is the length times width. We also know that the area of a square is the side squared. Because we don't know the side, we can use an x for our variable, or we can just use an s for the variable for the side. So first I'm going to look at my area of a rectangle. Area equals length times width. So I plug in 9 for the length and 6 for the width. Area equals 9 times 6, or 54. And of course I probably should have given it some sort of units, but of course this is inches squared. And I need to know the expression for the frame. Well, I know my area of the frame is going to be 54 inches squared, and I need to take out that area of the picture because the picture, of course, is being subtracted from the frame. So my area equals 54 inches squared minus my area of the square. I don't know what that is, but I can simplify it to s squared. So that's as simple as I can get until I know the unknown sides. So my area equals 54 minus s squared, square inches. Don't get s squared and square inches confused. Of course, it's always square units because remember, it's like drawing in a grid. So I hope that helps you. Now I want you to try to write and simplify expressions for the perimeter and the area of the rectangles and the squares. So go ahead and take a minute to pause this tutorial and practice these problems on your own. In this lesson, you have learned how to simplify expressions by using familiar formulas using perimeter and area of squares and rectangles. I hope you remember that algebra is everywhere, and we can use it in our daily lives. In fact, sometimes we're using it and we're not even aware we're using it. So another great job today, and keep up the good work.